Example 2 says solve the equation and what are the non-permissible values. So this one is an equation. It's different than adding and subtracting rational expressions because when I do that, I don't know what it's worth. But this one, I am actually subtracting these rational expressions, but it's equal to something. So it's an equation, which means I can cancel the denominators out. Okay, so I just have to make sure everything's factored in the denominator. This first one, already factored in the denominator. Second one, already factored in the denominator. The last one, not factored in the denominator. Okay, and I'm going to leave the numerator as is. Whoops, not B. How do I factor my denominator in this last one? Difference of perfect squares. Good. It's x or k minus 2 and k plus 2. Okay, so when you have the equal sign, you factor your denominators, and now you multiply each piece by the denominator that you want to cancel. Give me a denominator factor I want to cancel. Look here. Which one do I want to cancel? X plus 2. So I have to have an x plus 2, and I have to put it on each piece. When I do that, this x plus 2 cancels with this x plus 2. Nothing cancels here, but this x plus 2 does cancel with that x plus 2. What's the other thing I need to get rid of in my denominator? X minus, sorry, I keep saying x, k. K minus 2. So k minus 2's got to be something I'm going to times in there. Okay? First term, those don't cancel. Second term, the k minus 2's cancel. In the last piece, the k minus 2's cancel. So I have no denominators, which is what I like, because I don't like to deal with fractions unless I have to. Okay? First piece, though, I still have this 4k minus 1 there, and I do have to distribute it out with the other factor that's there. Now that k, that 4k minus 1 did not have brackets there, but I have to put it there, because it's this term times by that set of brackets. Okay? Minus this term here, k plus 1, times by a k plus 2 equals, and everything canceled over there except for what I originally had, so I'll just keep that as k squared minus 4k plus 24. Okay. No fractions, super nice, no denominators at all. All I have to do is distribute everything out, because it's a quadratic, it just is a wild one because I haven't distributed out these brackets. But once I get everything distributed out, quadratics, I put everything to one side, set them equal to 0, and I solve them by factoring if I can. Okay, so this one would be a 4k squared minus an 8k minus a k plus a 2. Okay, now this one's a little bit tricky. When you go to distribute this, do you see how you get k squared? But it's got to be a minus k squared. Then when you get 2k, it's got to be a minus 2k. Then when you get 1k, it's going to be a minus 1k. And then when you get this 2, it's a minus 2. Okay? I'm going to simplify this first side because it looks a little bit crazy. So 4k squared minus k squared is 3k squareds. Negative 8k minus another one is negative 9k. Minus 2 here, minus 1 there. Is that negative 12k? Is that what you did, really? I don't have that answer on my sheet. And then the 2 and the 2 cancel. On the other side, you have k squared minus 4k plus 24. Again, it's just a quadratic, but it's all mixed together. So we want to make sure that it's just all on one side. So I'm going to bring this term over by minusing it off, and I would get 2k squared. Okay. I'll finish it for those of you that can stay, and if you have to go, you go. Okay? This one I would add the 4k over, so this will be a negative 8k. And this one, I subtract the 24 over. Okay, now it's set equal to 0. I can pull out a 2. So I have a k squared minus 4k minus 12. And then I'm just looking at factors of negative 12 that add together to get negative 4. So that's going to be minus 6, so k minus 6, and k plus 2. what makes a 2 0? Nothing. It's 2. What makes this 0 would be 6. What makes this 0 would be a -2. And I just have to double check, are any of these non-permissible values? So back up at the top, are any of these non-permissible values? The 2 is, right? So I have to be a little bit careful about that. This one here is an extraneous root because it's a non-permissible value. So this one I would verify. Okay, back into the original equation. Okay, so if you do not start on the 6.4 homework, that is totally fine. Okay, however, you are